Imagine a fuel that powers our world, not just our cars, but our factories, our homes, and even the ships that cross our oceans. Now imagine that this fuel is so clean, its only byproduct is pure water. This isn't science fiction, it's the promise of green hydrogen, a revolutionary energy source that could transform the way we live, work, and move. Unlike traditional fuels that pollute our air and contribute to climate change, green hydrogen emits nothing but water vapor. It's a fuel that leaves no trace of carbon behind, making it one of the cleanest energy options available today. For decades, humanity has searched for ways to break free from the grip of fossil fuels. We've seen the damage caused by coal, oil, and gas, smog-filled skies, rising global temperatures, and a planet under stress. Renewable energy sources like wind and solar have made huge strides, but storing and delivering that energy when and where it's needed remains a challenge. This is where green hydrogen steps in as a game changer. Scientists and engineers around the world are racing to develop new technologies that make hydrogen production cleaner, more efficient, and more affordable. Green hydrogen acts as a bridge, storing excess renewable energy from the sun and wind. When the sun isn't shining or the wind isn't blowing, hydrogen can be converted back into electricity or used directly as a fuel, ensuring a steady, reliable supply of clean power. The green in green hydrogen means it's produced using renewable electricity to split water into hydrogen and oxygen, a process called electrolysis. This method generates zero carbon emissions, making it a truly sustainable solution. What makes green hydrogen truly remarkable is its potential to revolutionize industries that have been nearly impossible to decarbonize. Heavy industries like steel and cement manufacturing, as well as global shipping, can all benefit from hydrogen's clean energy, drastically reducing their environmental impact. Green hydrogen can even be blended into existing natural gas pipelines, helping to clean up heating systems in homes and businesses without the need for entirely new infrastructure. This makes the transition to cleaner energy faster and more cost-effective. By harnessing hydrogen alongside renewables, we unlock a powerful tool for building a sustainable future. It's a flexible, adaptable energy carrier that can help balance our power grids and support a wide range of applications. The journey toward a hydrogen-powered world is just beginning. Every day, new innovations are being made, and hope is growing that we can solve some of our planet's toughest energy challenges. Green hydrogen offers a real, tangible pathway to a world where economic progress and environmental health go hand in hand. It's a vision of cities with clean air, industries with minimal emissions, and communities thriving in harmony with nature. The future is bright, and with green hydrogen leading the way, it might just be powered by the cleanest energy source we've ever known. In early 2024, Indian scientists at the Center for Nano and Soft Matter Sciences made a breakthrough in green hydrogen. They developed a device that uses sunlight to split water into hydrogen and oxygen with impressive efficiency and durability. This tackles the biggest hurdles in large-scale green hydrogen production cost and stability. The Sense device runs for over 8 hours without performance loss, showing it's ready for real-world use. By using affordable, abundant materials, the team made green hydrogen more accessible. This puts India at the forefront of the global green hydrogen movement. Their innovation is a gift to the world, proving that science can solve our toughest challenges. This is science in action, changing the world one molecule at a time. How does this remarkable device transform something as simple as sunlight and water into a powerful, clean fuel source? Let's break down the science behind this cutting-edge technology. The process is known as photoelectrochemical water splitting, or PC for short. It's a fascinating blend of solar energy and chemistry, designed to mimic the natural process of photosynthesis. But with a twist. Here, the end product is hydrogen fuel. Imagine a solar cell, but instead of just generating electricity, it's submerged in water. When sunlight strikes the device, it energizes the material, creating a flow of electrical charges. These charges are harnessed to split water molecules into their basic elements, hydrogen and oxygen. At the heart of the PEC device are two key components, the photoanode and the cathode. These electrodes are carefully engineered to work together, each playing a unique role in the water splitting process. The photoanode is where the magic begins. It absorbs incoming sunlight, which excites the electrons in the material, knocking them loose and setting them in motion. These energized electrons travel through an external circuit to the cathode. Meanwhile, the photoanode pulls electrons away from water molecules at its surface, causing the water to split into oxygen gas and hydrogen ions. The freed hydrogen ions, or protons, then migrate through the water towards the cathode. When they reach the cathode, they combine with the incoming electrons to form pure hydrogen gas, which bubbles up and can be collected as clean fuel. On one side of the device, you'll see oxygen bubbles forming and rising, while on the other, hydrogen bubbles emerge. This visible separation is a clear sign of the water-splitting reaction in action. What makes PC technology truly innovative is that it combines the functions of a solar cell and an electrolyzer into a single compact unit. There's no need for separate systems or complex wiring. In traditional setups, you'd need a large solar farm to generate electricity, and then a separate electrolyzer to split water. The PEC device streamlines this process, doing everything in one step, right where the sunlight hits. This integration makes the PC system highly efficient, reducing energy losses and making the direct conversion of sunlight to fuel much more practical and scalable for real-world use. Indian scientists are at the forefront of this technology, developing advanced PEC devices that could revolutionize the production of green hydrogen, making it more accessible and affordable. Achieving direct sun-to-fuel conversion is often called the holy grail of clean energy. With PEC technology, we're getting closer than ever to a future where sunlight can be turned directly into sustainable hydrogen fuel, powering everything from vehicles to industries, all while producing zero emissions. The heart of the Sense device is its photoanode, made from silicon. Silicon is abundant, affordable, and already used in electronics and solar panels. But silicon corrodes in water and sunlight, until now. The team added ultra-thin layers of silicon dioxide and titanium dioxide to protect it. This armor keeps the silicon stable and efficient. For the catalyst, they used cobalt oxide, cheaper and more abundant than platinum. This combination of silicon, protective coatings, and cobalt oxide makes the device efficient and scalable. It's a masterclass in materials science. The design is stable, efficient, and built from earth-abundant materials. This could truly change the world. The Sense device stands out for its durability. It runs for over 8 hours under sunlight without degrading. This stability is essential for real-world use. It's also highly efficient, converting solar energy to hydrogen at rates competitive with the best global research. The process uses no fossil fuels, just light, water, and affordable materials. By avoiding rare metals, the device is cost-effective and scalable. Silicon and cobalt are widely available, making mass production feasible. This approach addresses the main bottlenecks: cost, efficiency, and durability. It's not just an incremental improvement, it's a paradigm shift. Green hydrogen could be produced wherever there's sunlight and water. This technology empowers communities to generate their own clean fuel. It's a powerful vision for a sustainable future. Not all hydrogen is created equal. How it's made matters for the planet. The process behind hydrogen production determines whether it helps fight climate change or makes it worse. Understanding the different colors of hydrogen is crucial for anyone who cares about our environment and the future of clean energy. Most hydrogen today is called gray hydrogen. It's produced from natural gas through a process called steam methane reforming, which unfortunately releases a significant amount of carbon dioxide into the atmosphere. In fact, for every ton of hydrogen made this way, up to 10 tons of CO2 can be emitted, making it a major contributor to global warming. Blue hydrogen is a step forward. It captures some of those emissions using carbon capture and storage technology. However, it still relies on fossil fuels as its primary source, and not all the carbon can be captured, so it's not a perfect solution. Green hydrogen, on the other hand, is made by splitting water into hydrogen and oxygen using electricity from renewable sources like solar and wind. This process produces zero direct emissions, making it a truly clean fuel from start to finish. The Sense device takes this a step further by using sunlight directly to split water, increasing efficiency and reducing energy losses. This innovative technology could make green hydrogen even more accessible and affordable in the future. Green hydrogen is the only truly climate-neutral option available today. It can be stored, transported, and used without adding greenhouse gases to the atmosphere, making it essential for a sustainable energy transition. It's especially vital for decarbonizing tough sectors like steel, cement, shipping, and aviation, industries that are responsible for a large share of global emissions and are difficult to electrify directly. These industries need high-energy fuels that batteries simply can't provide. Hydrogen offers the energy density and flexibility required to power heavy machinery, long-haul ships, and airplanes. By replacing fossil fuels with green hydrogen in these sectors, we can dramatically cut emissions and move closer to a carbon-neutral world. The difference between green and gray hydrogen isn't just about color, it's the difference between solving and perpetuating climate change. Choosing the right hydrogen pathway will shape our planet's future. Green hydrogen is more than just a fuel. It's the backbone of a sustainable industrial future, powering progress while protecting our planet for generations to come. India's breakthrough is part of a global push for green hydrogen. Countries worldwide are investing billions in research and infrastructure. As demand grows, manufacturing scales up and costs drop. Progress is rapid, with new electrolyzers, pipelines, and storage solutions emerging. But challenges remain. Cost is still the biggest hurdle. Green hydrogen must become as cheap as gray hydrogen to compete. This means more innovation and cheaper renewable electricity. Infrastructure is another challenge. Hydrogen is hard to store and transport. Upgrading pipelines and developing safe storage is essential. Public trust and safety standards will be crucial for widespread adoption. The race is on, but the path forward is clear. Turning a lab breakthrough into global change means scaling up. The next step is building solar hydrogen farms with arrays of PEC devices. Mass production and industrial automation will drive costs down. Factories could make PEC panels like today's solar panels. Government policies and investment will accelerate the transition. Infrastructure for storage, transport, and delivery must be built. Early projects in industry and transport will prove the technology. As costs fall, green hydrogen will go mainstream. The Sense breakthrough is a powerful tool for this journey. A hydrogen-powered world is within reach. Imagine a world where our skies are clear and our energy is clean. Green hydrogen can make this vision real, powering industries and communities sustainably. Local solar hydrogen generators could bring energy independence everywhere. Developing nations could leapfrog fossil fuels, building prosperity without pollution. Steel, fertilizer, and shipping could all run on green hydrogen, slashing emissions. This isn't just swapping fuels, it's redesigning industry for harmony with nature. The transition will create jobs, drive innovation, and build a circular economy. The Sense breakthrough shows the power of science and ingenuity. Every step toward green hydrogen brings us closer to a decarbonized world. The sun can now power our future, thanks to water, sunlight, and human creativity.